Here we have 4.4 complex zeros and the fundamental theorem, day 2. Finding a polynomial with specified zeros. So if we have this example where we have a polynomial, p, has a degree 3 and zeros 3, 2i, and negative 2i. What we can do is create factors for each one of these zeros. And to do that, we would subtract each of these from x. So x minus 3, x minus 2i, and then for the negative 2i, since we're subtracting a negative, it will be x plus 2i. So creating those factors, that one for 3, this one is for 2i, and then this one for negative 2i. Now we can multiply these together. So because these two are interrelated, I'm going to multiply those two first. So x minus 2i times x plus 2i, and you can use your special multiplication formula of a minus b and a plus b equals a squared minus b squared. So a minus b times a plus b, that's equal to a squared minus b squared. So here we have x squared because we have x times x. And because of how this works out, we can just go to the negative 2i times the 2i and get negative 2i squared. And so when we square the 2i, we get 4i squared. So x squared minus 4i squared. And if you can remember, I squared is equal to negative 1. So this is like having negative 4 times negative 1 to be positive 4. So we end up with x squared plus 4. So now we will take that and multiply by the x minus 3. And if you want to use the box method or FOIL method, whichever method you like, you go x squared times x to get x to the third. So that was x squared times x. Now we do x squared times 3 to get 3x squared. 4 times the x. Need a plus there. And we have, oh, you know what? That's actually a minus over there. So let me go back here and change this. So that was x squared times negative 3x to get minus 3x squared. And then we have 4 times x to be positive 4x. And then 4 times negative 3 is negative 12. And that is our polynomial with a degree of 3 from the zeros of 3, 2i, and negative 2i. Let's look at another example. In this example, we have a degree of 3 again, but we only have 2 zeros given to us, 0 and I. Well, if they only give us one complex value, there's another one that goes along with it. It's always going to happen. So if they give us an I, then we have a negative I also. If they give us negative 2i, then we have a positive 2i to go with it. So we have to keep that in mind, and that's where that third 0 comes from. So we're going to have a factor for the 0 of x, which is x. I'm sorry, yeah, the 0 of 0 to be x. A factor for the 0 of I, which is going to be x minus I. And then we have a factor for negative I, which is x plus I. So now we have our 3 factors. And again, the x minus I times the x plus I, just like the last one, is going to multiply and be a difference of 2 squares. So we have x squared minus I squared. So x squared minus I squared. And again, I squared is a negative 1. So this becomes x squared plus 1. Now we have to multiply in the third factor, the x. So I'm going to have that out here. And that's just distributing that in. And we get x cubed plus x. And that is our polynomial with a degree of 3 with those factors. Let's look at an example where we have a degree of 5. Here they give us 3 factors. Again, they give us a negative I, so we need to pair that up with a positive I. And they gave us some other restrictions here. They want a leading coefficient of 4, so we need to keep that in mind. And they also say that the 0 of -1 has a multiplicity of 2. So what that means is when we make that factor, we need to square that factor. That's what a multiplicity of 2 means. It's going to have an exponent of 2 on that factor because there's 2 of those factors. So we need to create a 0 for the 1/2, for the -1, and I'm just going to put a little asterisk there so I can remember, and then -I and +I. For the 1/2, we can start out with saying x minus 1/2, but we want to convert that because we don't want to have minus a fraction. So we can multiply x minus 1/2 times 2 to get rid of the fraction. And if we distribute that, we will get 2x minus 1. And that will be the factor that we're going to use. For -1, that's going to be x minus a negative, so plus 1. And again, we're going to square that. So 2x minus 1, x plus 1 squared. And if I want to square that, I have to remember that's x plus 1 times x plus 1. And I need to FOIL, and I get x squared plus x plus another x, and then 1 times 1 is 1. So I get x squared plus 2x plus 1. And that is done for that part. So -I it is going to be x minus a -I, so plus I. And then for the positive I, it's going to be x minus I. Okay, and just like before, x plus I and x minus I is going to give you a difference of 2 squares. So we take x plus I times x minus I, and we are going to get x squared minus the I squared, which converts to x squared plus 1, just like on the last example. Okay, so I've done some work in here already with my multiplying these factors together. So now I'm down to these 3. So 2x minus 1. I'm just going to go ahead and write the x squared plus 1, because those are both binomials, and I can multiply those pretty easily. And then the x squared plus 2x plus 1. So here we multiply, we get 2x to the third. I'm going to give myself some more room here. Multiply over here, I'm going to have positive 2x. And here I get negative x squared. And over here I get -1. So I'm going to write that in the proper order. So 2x to the third minus x squared plus 2x minus 1. Now, for those of you that like the box method, that's the same thing. You can do the box method and you'll end up with the same polynomial. Over here I have x squared plus 2x plus 1. And this is one of those problems where a lot of people like that box method. And if you don't know what the box method is, it's taking that 2x minus 1, writing it on the left-hand side of a box. You're creating 4 cells, and the other binomial or polynomial would go on the top, and you're multiplying here 2x times x to get 2x cubed, and you just fill in the box. You end up with these same factors here to simplify. So it's the same process as FOIL, just organized differently. I'm not going to finish that out. Okay, so 2x to the cubed times x squared is 2x to the fifth. 2x cubed times 2x is 4x to the fourth. 2x cubed times 1 is 2x cubed. I have negative x squared times x squared, which is going to be negative or minus x to the fourth. And then negative x squared times the 2x is going to be negative or minus 2x to the third. Negative x squared times the 1 is negative x squared. 2x times x squared is positive 2x to the third. 2x times 2x, I'm going to go down here, is positive 4x squared. 2x times 1 is positive 2x. Negative 1 times x is negative x squared. Negative 1 times x squared. Negative 1 times 2x is negative 2x. And negative 1 times 1 is negative 1. Now I need to put everything together and I'm done. So I get 2x to the fifth, 4x to the fourth minus x to the fourth would be 3x to the fourth. So I'm going to cross these out here. Let's see, 2x to the third minus 2x to the third, those two cancel each other out. We have another 2x to the third here to get plus 2x to the third. And then 4x squared minus 4x squared is 3x squared. And then we have 2x minus 2x, which is 0, and then minus 1. Okay, but now I have to remember that up above in my directions, I need a leading coefficient of 4. Let's see what my leading coefficient is. My leading coefficient is 2. So to get a leading coefficient of 4, I need to multiply this by 2. So I'm going to multiply everything by 2, and that will give me a leading coefficient of 4. So everything gets doubled. So 4x to the fifth plus 6x to the fourth plus 4x cubed plus 6x squared minus 2. And there is my final answer that satisfies all the restrictions. Okay, let's look at the last example here. And we have to find all zeros of the polynomial p of x, where we have x cubed minus 7x squared plus 17x minus 15. P is negative 15. I need the factors of negative 15. So anytime I have to find all the zeros and I can't factor the polynomial, I need to do this p over q to make my list of all possible rational zeros. So the factors of p are 1, so positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. And then my q value is 1, so that's just positive and negative 1. So that makes my possible list of zeros. My list of possible rational zeros is positive negative 1, positive negative 3, positive negative 5, and positive negative 15. So now I just need to do my testing. So let's go ahead and do my testing. I'm going to try 1 first. I like to start with the lower positive whole numbers. And my coefficients on the polynomial are 1, negative 7, 17, and negative 15. So I'm going to bring down the 1. 1 times 1 is 1. Add down, I get negative 6. Times the negative 6, I get 11. And I multiply and I get 11. And I add down, I get negative 4. So I didn't get a 0, but if you notice, I have alternating values here. And if you remember from upper and lower bounds, this is a lower bound. So my 1 is a lower bound. Okay? So now let's test another number. Let's try 3. And we're going to have our leading coefficients, 1, negative 7, 17, and negative 15. So we bring down the 1, and we're going to get 3. We add down, we get negative 4. We multiply, we get negative 12. Add, we get 5. Here we get 15. When we add, we get 0. So we get 0. And so then that's one of our zeros. Now the polynomial we get here is going to decrease by 1 exponent. So we get x squared minus 4x plus 5. And with that, we can factor that or use quad 3 on the calculator. And actually, we cannot factor that, so we have to use quad 3 or the quadratic formula. And using the quadratic formula, we're going to get the opposite value of negative 4 plus or minus the square root of 16 minus 4 times 1 times 5 all over 2 times 1. And if I do the math underneath here, I'm going to have 16 minus 20, which is negative 4. And so you can see that I'm going to get a complex 0 here. So I have 4 plus or minus the square root of negative 20. I'm sorry, negative 4 and change that. So 4 plus or minus the square root of negative 4 all over 2, which is going to be 4 plus or minus 2I over 2. And because we have both numbers up here, 4 and 2 can be divided by 2, we would simplify that and get 2 plus or minus I for our final answer, for our final 0. So we have our zeros that are 3, 2 plus I, and 2 minus I. That's a little sloppy. Let's write that over. 2 plus I. So those are our zeros, and we're done.